Hello friends, welcome to my YouTube channel. I am V. Tulasi Abhirami of first MSc Biochemistry. I am here to share my ideas about the topic MTT and Comet Assay. Let's get into the topic with MTT assay. MTT is the expansion of 3,4,5 dimethylthiazole 2,2,5 diphenyl tetrazolium bromide. This MTT assay is mainly used to measure the cellular metabolic activity as an indicator of cell viability, proliferation and cytotoxicity. And as we all know, this technique is an calorimetrical assay. The major principle or major concept behind this MTT assay is that the reduction of an yellow tetrazolium salt to purple formosyn crystals by metabolically active cells. This technique was initially introduced by Mossman, T et al. And further in subsequent years, it was followed by several other investigators. Let's see the principle. As I told before, MTT's principle is based on the reduction of the yellow tetrazolium salt to purple formosyn crystals, especially by the enzymes NADPH dependent oxidoreductase, which acts as a catalyst to reduce the MTT into formosyn. And this formosyn is insoluble, and in order to solubilize it, it is placed inside the solubilization solution, and then the color is obtained. And once the color is obtained, it is quantified or measured using the spectrophotometer or colorimetrically, and the nanometer set should be approximately of about 500 to 600, and it varies too. The darker the solution, the greater the number of viable metabolically active cells. And this picture mentions about the MTT as a principle in short, that is conversion of yellow MTT into purple formosyn with the help of the enzyme dehydrogenase, which is nothing but NADPH dehydrogenase. And this involves the conversion of MTT, that is reduction of MTT into formosyn as a chemical reaction. Let's see about reagent preparation. So in order to prepare the reagents for MTT solution, initially MTT is dissolved in Delbecque's phosphate buffered saline at pH 7.4. This solution is then filtered and it is sterilized through a 0.2 μm filter into a sterile and light protected container. It should be stored properly, otherwise it will cause several damages. And so in cases of storing, it should be stored at minus 20 degrees Celsius until analysis, or at 4 degrees Celsius for immediate use, and it should be mainly protected from light. Let's see about the protocol. So initially the protocol is very simple and short and concise. What they do is they actually load the cell suspensions in a 96 well plate. It may be with or without the test components, and then they are incubated at 37 degrees Celsius in an incubator which is maintained with 5% CO2 for required exposure time. Later, this MTT solution is introduced into this plate with of 10 μl is added to each plate until they reach a final concentration of 0.45 mg per ml. And once again it is incubated at 37 degrees Celsius for some 1 to 4 hours. Later that formosyn crystals, as it is told before, it is insoluble in nature. In order to solubilize it, it is placed in a 100 microliter of solubilization solution, and the absorbance is measured at 570 nanometer with a multiplate radar. So this is a short depiction of what I have mentioned in the protocol. So as it is told before, sealing is introduced into the 96 well plate, and the next step is introduction of MTT reagent with the help of the micropipette. It is incubated for some 3 to 4 hours. Then the reactions, that is a calorimetric reaction, that is reduction of MTT into formosyn, takes place, and which is mentioned here. And later the observed product, which is in color, is measured using spectrophotometer or colorimetrically at a wavelength of about 540 to 595 nanometer approximately. In order to calculate the value of MTT assay, the percentage calculation is used, and this percentage calculation is as follows. Percentage of viability is equal to mean OD sample divided by mean OD blank into 100. And the major application of this MTT assay is that it is used to measure the metabolic activity in living cells. It is also used to measure metabolic activity as an indicator of cell viability, proliferation and cytotoxicity. Next, let's see about Comet assay. So Comet assay is also known as the single cell gel electrophoresis. It's a sensitive technique for measuring the DNA damage. The main purpose of this Comet assay is to measure the DNA damage, and the principle is majorly based on the fact that damaged DNA, when the process of electrophoresis, damaged DNA can easily migrate out of the cell, and thus they create a comet tail. While the undamaged DNA, they remain inside the cell during the process of electrophoresis and forms the comet head. So this comet assay is and mostly it's run under the alkaline conditions in order to detect the single and double stranded DNA breaks, and also it can be done under the neutral conditions, but in order to determine the both double and single stranded DNA, it is advisable to use the alkaline conditions. And I have depicted the picture of this process, that is normal cells in conditions of when subjected to the electrophoresis. If it is undamaged, then it normally proceeds. In case of apoptotic cells, if there is a damaged and undamaged DNA fragments, so this damaged DNA fragments, they form the comet tail, and undamaged DNA fragments, they form the comet head during the process of electrophoresis. Let's see about the procedure. So this procedure is simple and smart. Here, the comet assay, as it is told before, it uses only single cell to measure the DNA damage. Initially the cells are placed into the agar solution, and then it is transferred to the slide. Now, the slide is immersed into a lysis solution to break and open the cell membrane. Once the cells are all lysed, the DNA is denatured, as it is told before, with either neutral or alkaline condition, but alkaline condition is better to use, and it is run through the process of electrophoresis. So, and already the cells are stained with the fluorescent or chromogenic dye, because when it is run under the process of X-ray or autoradiography, it is easy to identify them once if they are colored or marked with some known substances. So hence they are marked with fluorescent or chromogenic dye. The resulting image then, when is obtained, resembles a comet that includes a head and tail, and this image will be shown at the last. I have added the clip of this image at the last, we can see it. The comet head, as it is told before, consists of an undamaged DNA, and comet tail consists of unbroken DNA strands. And this process can be analyzed, and the results can be viewed on the system if sufficient softwares are installed in it regarding to this comet assay. And this is a glimpse of what I have seen today. This is comet assay when it is placed in agarose gel and it is transferred to the slide. Once it is transferred to the slide, the double-stranded DNA, when it is exposed to alkaline conditions, it gets single-stranded, it gets broken, that is single-stranded and double-stranded get separated, and then they get broken. Once they are broken, the broken strands form the head, comet tail, and unbroken strands form the comet head. Actually, this is the representation of a comet tail, comet head and tail. This is the overall view of about comet assay. And let's see about certain advantages and disadvantages. Certain advantages includes even a small amount of test substance can be easily identified or can be analyzed, and small sample volume is enough, and low cost, it is easy to apply, and short time is only required for application. As it has several advantages, it also possesses certain disadvantages, which includes that it is not able to detect small DNA fragments. It is not easy to detect the mitochondrial DNA damage, and certain apoptotic cells can be washed during lysis, and so it cannot be detected. Thanks for watching.